Hello students, today we'll be learning how to graph piecewise functions. So recall, a piecewise function is a function that's made up of multiple sub-functions, each pertaining to a portion of the domain. So looking at example 1, we've got the function f of x equals, and then it's a piecewise function. So just to talk about the notation a little bit, we use a curly bracket to represent the piecewise function. And within that bracket, there are, in this specific example, 3 sub-functions. So recall the sub-function, that is the 2x portion. So f of x equals 2x if, so these are our sub-functions. And we can insert the word if between the sub-functions and the subdomains. Okay, and I can use the word if. So f of x equals 2 of x if x is less than -1. F of x equals x squared minus 1 if x is greater than or equal to -1 or less than -2. And f of x equals 6 if x is greater than or equal to 2. All right, so now we have the task of graphing these. So I would suggest that you guys get some different colored pens or markers to graph with. All right, so the way that I like to graph these is I like to make a table. So I used to try to graph these by just looking at the function, graphing it as if it were kind of the entire function, and then erasing the portion which I don't need. However, this is a little tedious, and it actually doesn't really help me to understand what values pertain to what portions of this function. So making a table is a much better, or is the preferred method that we're going to use. Okay, so the first thing that I like to do here, I'm going to color code my function. So I am going to, let's call 2 of x, I'm going to make this my pink function. And then the middle part, I'm going to make that my green function. And then the 6 will be my blue. Okay. And this is just going to help us to kind of make our different partitions and to make the different pieces of the piecewise. So the first thing that I do before I make my table is I'm going to actually partition my graph. So I'm going to look at my subdomains. So my x is less than -1. So I know, and then in the second piece, the x has to be greater than or equal to -1. So I know at -1, there's going to be kind of a line there with 2 different components. So I like to make a dashed line at x equals -1. I'm going to make it dashed of green because the green part of my graph pertains, and also that pink. All right. Next, I see 2. So x is less than 2 for my green part. So I'm going to go to where x is 1, 2, and I'm going to make a dashed green. And then x is greater than or equal to 2 for the blue component, that third piece. So I'm going to make that blue dashing. Okay, now at the top of my graph, I'm actually going to label what f of x is for each of these portions. So in the blue portion here, which is greater than or equal to 2, f of x actually equals 6. Now this is just to help me because this is our first time graphing this, so I know what goes where. Now that middle component, that green part, that is actually where f of x equals x squared minus 1. And then the pink part, which is going to be on the left-hand side, will be where f of x equals 2x. So now within each of those parts of my domain, I can now graph each of those functions. Okay, so let's make a table. So we'll make our table of x and y. And when I'm choosing values to plug in, I'm going to pick values that are outlying my subdomains, or those values that are on those kind of borders of our domains, our subdomains, and then some values that are outside or inside of those, so outlying. So I'm going to start, just for preference, I start with the left function, or the function that's, I guess, the most left on my graph towards the negative x values, which is the pink. So I'm going to use pink when I label my values in my table. So I see x is less than -1 in my subfunction. So I'm going to pick that value as x. I'm going to say x is -1. However, x in this case is less than -1. It doesn't include -1. Okay, however, so if x were to be -1, at 2x, 2 times -1 would be -2. So at -1, there is going to be some sort of a point, because this 2x function is going to approach -1, but it's not actually going to reach it. But remember, it's going to include every single value up to, but not including -1. So the way that we represent that, just like we represent with a number line, is with an open circle. And I put that in a little note down there at the bottom. So because we have x being less than -1, at -1, -2, I'm going to have an open circle. Okay, I draw my open circle there. Now I am going to pick values that are on the left, on less than -1. So that's going to be on the left-hand side of my graph. So I can pick any value I want. I'm going to pick, I'll just pick -2. No, -4. We can pick anything we want. I'm going to put some dots in there. I'm not going to pick every single value in between. But if I were to find f of -4, I guess I should write it in function notation. So f of -4 in that portion would be 2 times -4, which would be -8. So I'm going to have -4, -8. In my graph here. And that's going to be a closed-in circle. And you can also use the slope. The slope here is 2. So from that first point that we found, I could just use my slope to find my other points. So I could go down 2, left 1, down 2, left 1. And that's another way that we can find other values if you don't really want to use the table. The table's just to help you. It's not a requirement. So some kids, if you can just graph these without using a table, that's perfectly fine. All right, now I'm going to move on to that middle component. So the middle component is green. On my graph, you can, if you don't have colors, that's fine. This is just helpful visually, I think, for me, and I'm totally a visual person. So, so now what I'm going to do, I need to pick a point. Oh, the other thing I wanted to know, I'm going to go back to my pink. Whenever I have a value in my table that's not actually a defined value in our graph, like that -1, excuse me, I'm going to star it, just so I know that this value is not actually in the domain. So in the green, x squared minus 1 at -1, I'm going to put that into my function. So if I'm finding f of -1, I would have -1 squared minus 1. 1 minus 1 would be 0. All right, so I am going to put the 0.01 here on that line. But I need to think, is this going to be a filled in circle or dot or point? Or is it an open point? Well, it's filled in because we have x being greater than or equal to. Remember that or equal to indicates that it's filled in. All right, now I'm going to do the same process. I can either use my, well, in this case, it's not a linear function, so I can't use the slope. So this is a quadratic. I might be able to just graph this, but I'm going to plug in my values. So I'm going to pick 0. If I were to find f of 0, 0 squared is 0, minus 1 is -1. So there's going to be a point there on the graph. I know it's a parabola. Parabolas are symmetric. So I can just fill in the rest of my graph. So I know there's going to be a point there. At 1, I'm going to have also 0. And I'm also going to do 2 because that's on my border there, on that partition. So at 2, first I need to look at my subdomain, and I see that x is less than 2, but not including 2. So I'm going to star it in my table, but I still need to find that because I still need to plot that as an open circle on that line. So f of 2 would be 2 squared minus 1. 4 minus 1 is 3. Whoops, and it is an open circle, not a closed-in circle. And there's my second piece. Now I repeat the process for that third component. Now this third part, the blue, it is just f of x equals 6 if x is greater than or equal to 2. Well, that's easy. F of x equals 6, that's like y equals 6. It's a horizontal line. So I know at 2, the function is defined. So f of 2 is just 6. Y equals 6, every value is going to be 6. So I'm going to go up to 6. I'm going to fill that in as a circle, a closed-in circle because it is greater than or equal to. And then every value above that is just also 6. So I'm going to do just a horizontal line. Okay, and there is my piecewise function. Now, you guys have another example. Please pause the video and you give it a try and see if you can graph that other piecewise function. Once you are finished, press resume, unpause, and watch me do it, see if you got the same answer. So for this function, I'm going to color code. Got my pink component, my green component, and my blue component. Then I'm going to make a table, X and Y. Before I can fill in the table, I'm going to make my partitions on my coordinate grid based upon the subdomains. So X is, so I see there is -3, which borders the pink and green parts of my graph. And then I have +2, which is going to border the green and the blue portions of my graph. Now I'm going to label the top, f of x equals -7 in this portion, f of x equals x squared in the middle, and f of x equals -2x plus 6. Now I'm going to make my table. So I'm going to start with my f of x equals -7. So that is when x is less than 3. Because there is no or equals to sign, I know at -3, my function is going to be at 1, 2, 3, 4, 5, 6, 7, -7. It's going to have an open circle down there. Then every value less than -3 for x is going to give me a y of -7. So I can put my little asterisk, -3 gives us a -7 represented there in that pink. Now I'm going to move on to my green. So the function itself is just f of x is x squared. That's our parent quadratic function. Right off the bat, I know how to graph that. I know it's just a parabola with no transformations whatsoever. So it's going to cross through the origin there. However, I need to make sure I evaluate that function at -3. So -3 squared would be 9. So I know at -3, my function's up here at 9. Because the function x is greater than or equal to -3, that's going to be filled in. Now I'm going to continue that parabola. If I were to, I know I have the point -2, -2 squared would be 4, -1, -1 squared is 1, 0 and 1. These are just all of those points in between. And then my parabola is symmetric, so I can bring those back up. So at 1, it's 1, 2, it would be at 4. But I need to look and say, is that included in this subdomain? Yes, it is, because I covered it up with my green up there. But this function is defined at 2. So that is going to be a filled in circle. And then I just smoothly connect those. Now I'm going to move on to the blue. Alrighty. All right, so x is greater than 2. So I already know 2 is included in the green. It's not going to be also included in the blue. That would be undefined. So I'm going to star that in my table. But when f of x, I still want to find that. I still need to evaluate f of 2 for that blue function, because remember, the graph is going to include every value up to 2, but not including 2. So we need to include, 2.00000001. So the easiest way to do that is to just find f of 2 and leave it as that open circle. So f of 2, if I were to plug that in, remember we're finding f of 2, I just plug that into my formula, or into my equation, -2 times 2 plus 6. So -4 plus 6, that would just be 2. So I'm going to go over here to 2, 2, and I'm going to put an open circle. All right, so from here, like I said, you guys can just use slope if that is helpful. It's a linear function. Or you could plug values in. Let's say I wanted to just plug in the value of 3. So 3 times -2 is -6, plus 6 is 0. I'm going to plot that point. I can also use the slope. The slope is -2, so I can go down 2 over 1, rise over run, and there is my third part of the function. How'd you guys do? Hope you did well. Next, we'll be learning how to apply piecewise to some real-world applications.